Hello and welcome. In this episode, we'll solve Leetcode problem max area of island. This is a medium level problem and we'll solve it step by step using depth first search algorithm. So let's dive in. So we are given an n by m grid where land is represented by ones and water by zeros. Our goal is to find the largest connected piece of land, an island. If there is no island, we return 0. Think of an island as a group of connected ones. Two land cells are connected if they are adjacent, up, down, left, or right. Diagonal connections don't count. We'll solve this problem using depth-first search algorithm. We will run a loop through each cell in the grid, and on each step we check the value in the cell and mark it as visited. If we find one, which is a land that hasn't been visited, we start DFS. Explore in all 4 directions, up, down, left, and right, until we reach water or go out of bounds. Also, we will count the number of connected land cells and keep track of maximum island size. We'll use a hash set to mark visited cells so we don't count the same island twice. Now it is time to implement this algorithm in Python. We start by defining variables for the width and height of the grid. Rows will be the length of the grid array, and cols is the length of the first row. Next, we define a hash set to keep track of visited cells. Then we define DFS function, which we will implement later. Now we iterate over all cells in the grid and check if the cell has not been visited and if the value is 1, which means we found land. If both conditions are met, we start DFS. And now let's go back to the DFS function and implement it. First, we need to check if we go out of bounds. If row is less than 0 or equal to the total number of rows, or if column is less than 0 or equal to the total number of columns. In these cases, we return 0. Additionally, if the value in the cell is 0, it means we have left the land. Also, if the cell has already been visited, we return 0. Finally, we explore all adjacent neighboring cells, top, down, left, and right, by running the DFS function recursively. At this point, we know we are on the land cell, so we initialize our res variable to 1 and add results from the recursive DFS calls. We return this value at the end of the function. Now, in the loop, we can store the result of the DFS function and keep track of the maximum area, which will be our final result. Now that is it. This is a working solution. One improvement we can make is modifying the grid in place instead of using a hash set for visited cells. We do this by changing the values of visited cells to -1. Instead of checking if the cell's value is 0, we check if it is not 1. After visiting a cell, we change its value to -1 to mark it as visited. In terms of time complexity, the solution is m by n, since each cell is visited at most once. In terms of space complexity, it is m by n as well, if we use hash set to keep track of visited cells, and it's O1 if we use in-place modification. That's it. We've solved max area of island using DFS. This problem is great for practicing DFS traversal in the grid.